Hello everyone, this is Eason Lee from Think Academy Singapore. Today we are going to talk about an extreme value problem. Actually, next day will also be extreme value as there are always one or two questions in each year's paper and there are many different kinds of extreme value questions, so are divided into two parts. So this day we are going to talk about extreme values in calculation problem and the next day would be a combinatoric. Now about calculation, it's much more easier as we are maybe much more easier to find extreme conditions. So we just need to constructing the final answer, right? So in the first round, there is something that tested a lot is about. So if there are two numbers A and B, right? If the sum is determined, then to make the product as large as possible, we should make the difference as small as possible. So this is something that the first round always asks us, but it's the special round, however, so this is maybe too easy for it. So it may be something, some method in the combinatoric, but it's not a solo question. In the special round, the calculation is always combined with the number puzzles. So, for example, now here comes the 2019 problem. So here comes the 2019 question. Its last question was 5 points. So there is a formula here that we should use 1 to 9 ones to form it to make the answer as large as possible. And we should make the final answer to be an integer. So first of all, so let's write this down in another formation. So here is B divided by C, D times F divided by E, and minus AG and minus NH divided by J, sorry. So here include 4 different calculations, right? So now, let's talk about the scene. So how to make this formula as large as possible. So to make the answer the largest, the most important thing we should rely on the production, right? One times another is the most efficient way to make the answer larger and the largest of its kind, right? So first of all, there is only one multiple here, which means we should make D and F as large as possible. So this is maybe we put a 8 here and the 9 here, right? Then it's divided by E. So a division is not something that we don't like, right? So it makes numbers smaller and it make numbers smaller in a very efficient way. So to avoid it, we made this E as small as possible. So we put the smallest number here as a divisor, which is a 1. Okay. Then again, we come back to another. So about addition and subtraction. So for addition, we want the number to be as large as possible. For subtraction, we should make a number as small as possible. So here is a plus A and a minus G. So now we just put the largest number to A, so which is remaining is a 7. And the smallest number to G, with the remaining is a 2. So this is the way we can do to make this as large as possible. So what about B divided by C or H divided by J? So we know that there's a division here, right? So in a division, so the efficiency of the denominator is reduced. For example, if you write so 5 and 6, they have a difference of 1. But 5 over 2 and 6 over 2, they only have a half of its difference. So, this A and G here, they is one of its kind, but B and H is smaller than one of its kind. So it has low efficiency in influencing the answer. So maybe this is, I don't know how to speak it accurately in English, sorry. But I think you know what I mean, right? So the largest number and smallest number should be put in the 1's digit. So this is put in less than one digit. Yeah, maybe. So, then finally, it's the way we look back at b divided by c and h divided by j. So, which is a fraction. And now we come back to this, that we should make this an integer. So how to make this an integer? Of course, c and j are different denominators. So how can two different denominators calculate it as an integer? So first of all, they should have a common factor, right? So what is the common factor? What's the number remaining? So the remaining number is 3, 4, 5, and 6, right? So if you want to choose two from it that shares the same factor, so there is only two choices. So 4, 6 or 3, 6, right? So maybe let's try it out. So if it's a 4 and a 6, so maybe a 6 minus 4, so I'm not so sure, right? So for 6 here, right? For 6 here, 8 has a factor of 3, which should be simplified. So we should put a 3 here. So we can only put 3 here. Then only a 5 here, but this is not an integer. So we failed. So not 4 and 6, so can only be 3 and 6. Again, yeah, maybe a 6 minus 3, we don't know. But here, again, so 3 here, for 6, it has a factor of 2, which should be simplified, so we should only put a 4 here. And a 5 here, then let's examine it. So this is 5 over 3, so this is 2 over 3, so the answer should be just 1. Yeah, that's correct. Yeah, that's what we need, right? So then, yeah, we can put the answer together. So it's a 7, 5 over 3, 8 times 9 divided by 1, minus 2, they are minus a 4 over 6. So calculate it out, 72, 79. Yeah, 79 plus a 1 minus a 2, so it's a minus a 1. So the answer is 78. So you can examine, there are many possible different answers, but the largest one should just be the 78. So for this question, yeah, it's important to know that the efficiency of changing the answer of a formula here. So the most efficient way is by the production, and then addition and subtraction, and then the sum numbers that beneath one unit, one digit, right? So it was less than 1 of itself. So this number, so it counts the last. And for the final step, we then try to make it an integer. So since it occurs that if, in this case, we cannot make it an integer, so maybe we made some adjustment. Maybe we change a 2 into a 3, or change a 7 here into a 6. But I don't think 7 to 6 can help, as 7 is a prime number, so it cannot be the denominator, right? So maybe just change 2 into 3, maybe we can get another answer here, right? Okay, now that's for this question. That comes in the 2017. So this is only a 4-point question, but I don't think it's easy. So in here, this is a column puzzle, which we should use 0 to 9, all the 10 numbers each once to form this. And we should know the sum here to be as large as possible. So for this question, right, it's okay for you to just try. Maybe we make a treasure as large as possible, maybe try from 897 or maybe 896. So just trying from the largest to the smallest. So keep the 9 unchanged. It's just meant for the I and j to find the answer. So this should be the way, but it may take you a lot of time, right? So yeah, to finally get an easy way to reach the answer, we should learn a thing. So this is what I want to tell you about a certain column puzzle, which that the 0 and 9 here, so occurs, or maybe just say all occur. So there is a certain type of question if this 10 number all occurs once, or maybe just one absent here. For this question, we have a special way to solve it by using the remainder of 9. So now, first of all, let's look at this. we know that A, B, C, D, E, F, G, the sum is H, I, J, right? Then we also know that a number shares the same remainder as the sum of its digits when divided by 9. So which means we can get A, B, C, D, E, F, G. So this shares the same remainder of the left, and this will share the same remainder of the right. So the sum of digits of the addition, the three numbers here, should have the same remainder as the sum of digits of the sum. Then we also know that the 0 to 9 occurs each once, which means that we know that A to J, the sum of it is just equal to 0 to 9, which is 45, so which has a remainder of 0 when divided by 9. So we need to make the remainder of 0 two parts, and they share the same remainder when divided by 9. So there is only one conclusion, that both parts should be the multiple of 9, right? So there is no other solution. Maybe they should remainder 1, 2, 3, 4, 7, 6, 5, 6, 7, 8. So all the 8 other conditions cannot make its sum the multiple of 9, okay? So then we will find that 9 should be divisible, should be factor of H, I, and J. This is a very important hint for us. So maybe we just try 7, 8, 9 here, which is absolutely not possible, as the sum of 7, 8, and 9 is not a multiple of 9, right? So then, to make it a multiple of 9, we should know that H is larger than positive, so make H to be 9. Then I plus J should also be a multiple of 9. So if 9 is put here, so I plus J should be a multiple of 9, so which can be 8 plus 1, 7 plus 2, 6 plus 3, 4, 5 plus 4, or things like that, right? So then we narrowed our choices, right? Then again, right? So we know the sum of digits of the sum to be 18. Then the total sum of number is 27 here, right? So 27 here. Yeah, so it's 45 here. So the sum of digit of the number here should be 27, right? And then we know that there should be a carryover for E to H. And when we're talking about carryover, we should know that a carryover has an influence on the sum of digits. So if we put the sum of digits of the three numbers together, so if there is a carryover, we know that the carryover is make a 10 into a 1 in a higher digit, right? So 1 carryover should make the sum of digits minus a 9. So by looking at the sum of digits, we can find the time of carrying over. So which makes here, so 27 to 18, there is a 1 9 missing. So there is 1 carry over in this addition. And this 1 carryover absolutely happens here, right? So E should be an 8. E should be an 8. So this is 1 carryover. We found the E is 8. So I should not be 8. Maybe try from 7, 2, or 6, 3, right? Then again, here we use the carryover. So to the 1 digit to 10 digit, there should be no carryovers here. So if there is a 7 and 2 here, so BDG has a sum of 2 with no carryover. Is that possible? No, right? So smallest choice is 1, 0, and 3. So the adding up is 4, not a 2 here. So which means 9, 7, 2 is not possible. Then 9, 6, 3. Yeah, can BDG has a sum of 3 with no carryover? Absolutely yes, right? Just 0, 1, and 2 here. Then you will find that we know the number of sum of digits we have found a carryover. So just you randomly adding all the 3 remaining number in here, it will always do the same. So the remaining number is a 4, 5, and 7. So 4 plus 5 plus 7 is just a 16. So 1 is a carryover, so make it perfect. So the largest number here should be 9, 6, 3. So to solve this problem, there are many things we should learn. So first of all, the sum of digits and the connection to the sum of digits with the carryover time. And then we can finish this problem. So in this question, I think you should remember this. So in a column puzzle, if 0 to 9 all occurs or only one absent, you can always use this way. So use the sum of digits and the remainder of 9 to solve the problem. Okay, that's all for today, and thank you, and see you tomorrow.